वेलकम टू सहायक एजुकेशन। सहायक एजुकेशन में आपका स्वागत है। 10th क्लास की मैथ्स की सीरीज के अंदर आज हम बात करेंगे सरफेस एरिया एंड वॉल्यूम की, विच इज द 12th चैप्टर ऑफ एनसीईआरटी सीबीएसई। ओके, सो विदाउट वेस्टिंग एनी टाइम, लेट्स स्टार्ट विद द चैप्टर। It's a very small chapter and you have learned about it in the ninth standard, so I believe it will be an easy one for you. And please subscribe to the channel in case you want to receive more updates. And before the exams, I want to tell you again, before the exams, we'll be publishing one more video covering all the chapters together, which will help you in getting better scores. Okay, so let's start with the chapter Surface Area and Volume, class 10th. It's a chapter 12th. This chapter contains 6 to 7 marks in the exam. 6 to 7 marks in the exam. So it'll somewhere around 2 questions from this exam, from this chapter will be there in the exam, and there'll be one small and one long question, maybe a 5-marker question, will come from this chapter. Okay, so we have learned about common 3D shapes. Cube क्या होता है, cone क्या होता है, okay, sphere क्या होता है. तो this is something बच्चों को बचपन से पढ़ाते हैं. So I believe you must be knowing what is this called a cylinder. Okay, it is not the gas cylinder. Cylinder आपको पता होना चाहिए cylinder क्या है. Cone, you know, okay, softy सबने खाई है, तो softy का cone रहता है ना, आइसक्रीम cone रहता है. So everybody knows about that. And cube, we play dice games. So the dice is a cubical shape, and moreover we also have a Rubik cube, so people know what is a cube. Cuboid, okay, it is where length, breadth, and height, okay, they could be different. And sphere, football, basketball, and all those kind of shapes are called spheres. We have learnt about area and volume of various shapes. Like if I talk about a cuboid, the curved surface area comes out to be 2h into L plus B. Okay, that's the curved surface area, and total surface area covers the entire thing. That is 2 multiplied by LB plus BH plus HL. And the volume is length into breadth into height. Okay, one thing I want to tell you, say in case we are taking a regular figure, because sometimes people don't remember this formula or they don't remember this formula. So just wanted to tell you how to remember these two formulas. Now, when we're talking about a figure which is uniform figure, now the volume of cuboid will be area of base multiplied by height. Okay, if we can compute the area of base and multiply it with height, it will give you the volume of the cuboid. In the similar manner, in case we have a cylinder, again it's the same thing. You need to find the area of base and multiply it by height, and we'll get the answer. So in case of cuboid, what will happen? Area of base is length multiplied by breadth, and if you multiply it by height, it will give you the volume of it. In case of a cylinder, the area of base multiplied by height, it says volume of cylinder multiplied by height. So what is area of base? The area of base is pi r square. It's a circle, and multiplied by height. So when we multiply the base with height, it will give you the entire volume. So please remember that if for a uniform figures, basically for cuboid and for cylinder, if you have the area of base, you might not know length and breadth, but if you have the area of base, you multiply it by height, you will get the volume. In the similar manner, in a cylinder, if you have the area of base, okay, maybe you don't even have the radius, still you can find the volume because you have the area of the base just multiplied by height, and you'll get the answer. Okay, and see, in this chapter we'll be discussing about various shapes which are combined shapes. They're combined shapes. Okay, before that, please remember curved surface area. Curved surface area is which is a curved or which is non-horizontal, which is curved or it is non-horizontal. So please remember this part. If we talk about a cone, say, I just clear it up. So if we talk about a cone, this is the base of the cone. And so this part of the area will be the curved surface area. Okay, we'll not cover the base. Okay, the base will not be covered here. Okay, this part is a flat surface, so we'll not cover that. Okay, this is the curved surface and this is the flat surface. So flat surface will be horizontal. Mostly it will be horizontal. Okay, and curved surface will be either vertical or tilted. It could be anyways, or they could be curved. And curved surface and lateral surface, we sometimes use them interchangeably. So please don't say that, okay, they asked for lateral surface, but we have the formula for curved surface. So curved surface and lateral surface area is kind of same. Okay, so coming to, there are certain points we should note. That is, if we melt a solid and cast it into another solid shape, the volume remains the same. The surface areas might change. The surface areas might change, but the volume remains the same. The volume of the matter remains the same. This is actually related to physics, that the volume of the matter will remain the same at the same temperature, whether the whatever different shape it can have at the same temperature. Okay, so in mathematics, they will not say the temperature has gone up and down. Those kind of questions will not come. So you can assume that the volume of the matter will remain same. The second thing is that the total surface area will always be greater than curved surface area. Will always be greater than or equal to. So in case of a sphere, it will be equal to. Okay, curved surface area and the total surface area is same. But in other cases, it will always be greater than the curved surface area. Now coming to combination of shapes, say in this chapter, we will have to find the surface areas and volumes of combination of shapes. They will not ask you directly that what is the total surface area of a, a cube. They will not ask that. This kind of question. This is a very basic question. They will not ask this kind of question. They will combine it with something that, okay, on top of a cube, there is a cone. There is a cone, and then we have to find the total surface area, and we have to remember that we'll find the total surface area of the entire cube, and then we should subtract, because this part is not coming in the total surface area. Okay, we should subtract it, and we should add the curved surface area of the cone, in this case, which I've the figure which I've made. Combination of shapes. So you can see it could be a hemisphere and a cone, and they are joined together to make some kind of toy, or it could be one cylinder and a cone, they joined to make a hut. Okay, it could be a pencil kind of a thing. So this is a hemisphere. Okay, this is hemisphere, then this is cylinder, and this part is cone. So basically three things they have joined together. Now there could be a cube, and on top of it they added a cylinder. I just write it as a cylinder. There could be a cube, and then on top of it is a hemisphere. Then again, we have a half of cylinder. This is a half cylinder. Okay, half cylinder, and this is a cuboid. So there could be various shapes which will come as a combination, and we have to find the total surface area. So the imagination of how exactly the surface will look like, how exactly the object will look like, is very important. Imagine that thing and draw the figure to understand it. So for every question, you have to draw a figure in this. In other questions, you don't draw it, but in this chapter, for every question which is given to it, it's better to draw. Okay, if it is not a straightforward question. Okay, so let's do some examples to practice a little. Rashid got a playing top, Lattu, as a birthday present, which was surprisingly has no color on it. He wanted to color it with his crayons. Very good, very creative boy. The top is shaped like a cone surmounted by a hemisphere. Now, surmounted means it's on top of it. Surmounted means on top of it. The entire top is 5 centimeter. The entire top is 5 centimeter, which is mentioned there. And the diameter of the top is 3.5 centimeter. The diameter is also mentioned as 3.5. Find the area he has to color. So he has to color the complete toy. So when he has to complete color the entire thing, so that means he has to color the sphere. And what is the area of sphere? Yeah, so area of sphere is equal to 2 pi r square, and area of cone is equal to pi r L. Okay, we have to compute L because we don't know L. So let's make this is L. Let's consider this as height. So height will be height, and this part is, say, radius. Okay. Now we know that R is equal to 3.5 divided by 2. And let's compute H. So H is equal to 5 minus 3.5 by 2. It comes as 5 to the 10. 10 minus 3.5 is 6.5 divided by 2. So height comes as 6.5 divided by 2. Now we have to find the value of L. Let's find the value of L. So L is equal to square root of h square plus r square. This comes out to be square root of h square is 6.5 by 2 square plus r square. R square is 3.5 by 2 square. And this value comes out to be somewhere around, let's compute it, it is 3.69. This value is coming somewhere around 3.69. So we can say L is equal to 3.69. Now the total surface area of this toy is equal to 2 pi r square plus pi r L. So we'll compute what is common in this. Pi is common. We can say 2 into r square plus r is also common. No? R is also common. So I'll just say eraser. So what is common in these two? It's pi and r. It's same. So what is left? 2r plus L. This is left inside. So let's put the values to get the answer. It is 22 by 7 into r. Radius was 3.5 divided by 2. And that comes out to be 2 into r. So that means 2 into r is 3.5 divided by 2 plus L. L we have found is 3.69. Okay, and when we compute this, this is 3.5 2s, and is this 2 into 11? So it comes out to be 11 divided by 2. 2 will cancel out. It is 3.5 plus 3.69. So 3.69 plus 3.5, 11 is 5.5 multiplied by, it is 9. And 6 and 5, 11, 1. And it comes out to be 6. It's 7.19. 7.19 into 5.5. And this value comes out to 39.545. 39.545 centimeter square. Okay, two things you have to remember here. The first thing is that whenever you're computing something, please write the unit. If you don't write the unit, you'll lose half a mark, 1 mark. Okay, it depends on teacher's mood, how much they want to cut if you have not written the unit. So please write the unit properly. A centimeter square. So if we have found the area, the unit of the area will be centimeter square, meter square, or it will be square units. So please mention the unit here. A second thing which I want to tell you here, see, when we have taken the area of the sphere, okay, we have not taken the complete total surface area of it. We have only taken the curved surface area of it. Reason is, this is the sphere, and here is the cone. This part of the area of the cone we have not taken. Why? Because it's not part of the total surface area. It's not be seen from outside. And this part of the sphere we have not taken because this is something which is not seen from outside. You cannot paint it. It is inherited. It is part of this structure itself. So we will not take something which is not even seen, we can't paint something which is not even seen, which is inside a particular product. So don't just take by heart the formula and just do it. The total surface area of the sphere of hemisphere comes out to be 3 pi r square, because 2 pi r square for the curved surface and 1 pi r square or single pi r square for the straight surface or for the flat surface. So don't just compute it on the basis of your formula because you remember the formula. Please visualize the shape and see how exactly what will it contain. It is not you have taken the area of this plus this is equal to the total. No. Okay, you have to omit the common parts. Okay. First thing, you have to ensure that you are writing the unit. Second thing, please visualize the shape and take only something which is relevant shape. Okay, so coming to the next question now. It says a decorative block shown in figure is made of 2 solids. Now, okay, again, see, they have made a cube here. I think it's a cube. Yes, it's a cube. Okay, it's a cube and it's a semisphere or hemisphere. Okay, the base of the block of the cube is 5 centimeter and the hemisphere fixed on the top of it. Top has a diameter of 4.2 centimeter. Find the total surface area of the block. Okay. For finding the total surface area, what is the total surface area of a cube? The total surface area of a cube is 6a square. If the side is a, so it'll say a is equal to 5. If I consider this side as a, okay, a, so the total surface area is 6a square. But please remember that this part is not in the structure at all. This is something which is inside the structure. So we have to subtract this part. And what is this part? This is a circular part. This is a circular part. So what we have to do? It is circular. What is the area of a circle? It's pi r square. So when we have to when you have to compute the total surface area of the structure, then we have to omit this part. So let's find total surface area. This is of cube. Okay. And a curved surface area of sphere is equal to 2 pi r square. Now, total surface area of structure is equal to 6a square. So we have considered the total area of the cube, but we are subtracting. We are subtracting what? We are subtracting the area of the circle. Area of this circle, which is given here as pi r square. And then we are considering the area of the sphere, that is 2 pi r square. Okay, so pi r square. So 1 pi r square will cancel out. So it becomes 6a square plus pi r square. Okay, now let's put the values now. It is 6 into a square. A is 5 into 5 plus pi. I can take pi as 22 by 7 into, what is the radius? So diameter is given as 4.2. The radius is 2.1. 2.1 into 2.1. So 7. 3s are 0.3s are 2.1. So let's compute it. It comes out as 6 5s are 30, 35s are 6 5s are 30, 35s are 150. 150 plus 22 into 0.3 multiplied by 2.1 comes out to be 13.86. So it becomes 163.86 centimeter square. So this is the area of the structure. Please remember to write the units. It is pretty important. Okay, so coming to this question, it says a wooden toy rocket is in the shape of a cone mounted on a cylinder, as shown in the figure 12.8. The figure of the entire rocket is the height of the entire rocket is 26 centimeter, while the height of the conical part is 6. So if this is 6, the height is 6. Height is 6. The rest of the part, basically from here till down, or you can say this distance, is 20 centimeter. This is 20 centimeter. That means the height of the cylinder is 20 centimeter. Okay. The base of the conical portion has a diameter of 5 centimeter. So this base has a radius of, has a diameter of 5. So the radius is 2.5. While the base of the diameter of the cylindrical portion is 3 centimeter. Okay, so this is 3 centimeter. Okay, it's 1.5 centimeter is the radius. 1.5 centimeter. If the conical portion is to be painted orange and the cylindrical portion to be painted yellow, find the area of the rocket painted with each of these colors. Okay, so we have to paint the top part as orange and the cylindrical part as yellow. Okay, so for orange paint, area is equal to, okay, first we need to take the lateral surface area of the cone. So lateral surface area is pi RL. Okay, its radius is different here. It is not the same radius as of the cone. This is the radius, this is 2.5 here. And plus, see, it's under the cone, okay, under the cone, this is the kind of shape which is made, okay, where this part needs to be painted as orange. This part needs to be painted as orange. If this part needs to be painted as orange, because this is an additional part which will be seen. So this part has to be painted as orange. So how will we find it? We'll find it as the circle. It's a circle, so we'll say pi r square minus pi r square. The area of the bigger circle minus area of the smaller circle. So pi is common. I'll take r. Radius is 2.5 square minus 1.5 square. So it comes out to be uh, pi common, and then it is 2.5. It is a plus b into a minus b. It comes as 4 into 1. So it comes as 4 pi. So the area of the shaded region here is 4 pi. So this is pi RL plus 4 pi is the area for the orange part. Let's compute it. Okay, we don't know L. We don't know L. So we need to first compute L. So how will we compute L? We know the, okay, this is L. This is called as L, lateral height. Okay, so to compute it, we can say L is equal to square root of 6 square plus 2.5 square. So 6 square is 36 plus 2.5 square is 6.25. So it comes as square root of 42.25. 42.25 is the square root something. I'll just figure it out. 42.25. So it's the square of 6.5. Okay, this answer comes to be 6.5. So the L is 6.5. This distance is 6.5 centimeter. This distance is 6.5 centimeter. Now let's calculate. So both of these, pi is common. I'll take radius. Radius is 2.5 multiplied by 6.5 plus 4. So it comes as pi. 2.5 into 6.5. 5 into 2.5 comes out to be 16.25 plus 4. So it gives 20.25 pi. Let's take pi as 3.14 as mentioned by them. So this is 20.25 multiplied by 3.14. It comes to be 63.585 centimeter square. So please remember this part. Please, that unit needs to be mentioned. If you don't mention the unit, then you will lose a few marks. So please remember to write the unit with in every question. Okay, so this is the first part. Now, second part is we have to paint certain thing as yellow. Okay, for painting the yellow, see, we need to take the entire cylinder, but we will not have to take the top part, because this top part, this the 3 centimeter which is shown here. Okay, we cannot take this part because it's inside. It's inside the rocket. It is not seen outside the rocket. This 3 centimeter. So we'll take this complete area plus the area of the base, which will be painted. So the area of the base as well as the lateral surface area of the cylinder. So we'll say a yellow part or yellow paint, this area is equal to, see, we have to take the curved surface area, that is 2 pi r. This r is different. Okay, this r is not 2.5. This r is 1.5 because the radius of the cylinder is different than the radius of the cone. So it is 2 pi rh plus pi r square, the base. Pi r square is for the base. This base, pi r square. So we are taking the base. You have to paint base as well. So what is common in this? I can say pi r is common. What is left? Pi r is common. So 2h plus r. So I'll just write it as 3.14 into radius is 1.5 and is 2 times 20 plus r. R is 1.5. So it comes as 3.14 into 1.5. It is 20 into 40, 240. 40 plus 1.5 is 41.5. And if we compute it, it comes out to be, we can make some computation mistakes. So be cautious on that. It comes out to be 195.465 centimeter square. Okay. So let's move to another question. What does this question say? It says, Mayank made a bird bath for his garden in the shape of a cylinder. Okay, it's a bird bath with a hemispherical depression at one end. So this is the hemispherical depression of at one end. The height of the cylinder is 1.45 meter. So see, this is in centimeter and this is in meter. So let's convert it into centimeter itself. So I write it as 145 centimeter. Okay, we should take the unit in the same metric. We cannot take different metrics for computation. Okay, by now you must be, you're in 10th standard, you must be understanding this. And the radius is this much. Find the total surface area of the bath. Okay, so the total surface area of the bath, we can take the curved surface area. We can take the curved surface area of the cylinder, the curved surface area of cylinder plus total surface or total surface area of object is equal to curved surface area of cylinder plus we need to take the curved surface area of the depression. Okay, the depression is in the shape of a hemisphere, so we'll take it as curved surface cylinder plus curved surface area of hemisphere. So this comes out to be curved surface cylinder is 2 pi r into h, and luckily the radius is same. CSA for hemisphere is 2 pi r square. So what is common? 2 pi r is common. It comes h plus r. So let's put the values. 2 into, I'll take it as 3.14 into radius is 30. Radius is 30. Yes, radius is 30 centimeter. Height is 145 plus radius is 30. So it comes as 30 into 260. 60 into 3.14. 145 plus 30 is 175. So let's compute it. 175 multiplied by 3.14 multiplied by 60 gives us 32970. It gives 32970 centimeter square. Okay, and if we have to convert it into meter square, what we are going to do? We are going to divide by, because see there are 2 centimeters and we have to convert centimeter square. Okay, let me make you understand this. It is written as 32970 centimeter multiplied by centimeter. There are 2 centimeters, right? So for every centimeter, we need to convert it into meter if we want to convert it into meter square. So it comes as 32970, and I can write centimeter as 1 by 100 meter into 1 by 100 meter. Okay, so this comes out to be 3.2970 or 3.297 meter square. Okay, so coming to the first question of NCERT 12.1, 2 cubes each of volume 64 centimeter cube are joined end to end. Find the surface area of the resulting cuboid. Okay, it's a straightforward question. First of all, they have given the volume of it. So we know volume of a cube is equal to a cube. Length into breadth into height, all are same. So it is a into a into a. It becomes a cube. And volume is given as 64 is equal to a cube. So a comes out to be 4. That means the side of the cube is 4. Now they are saying 2 cubes are joined together. When the 2 cubes are joined together, let me just make the figure. How exactly it will look like. This is 1 cube and this is another cube. Okay, so the 2 cubes are joined together. So if this side is 4, this side is 4. Now it becomes a cuboid. It becomes a cuboid. Now the length of the cuboid is 4 plus 4, that is 8 centimeter. What is the breadth of the cuboid? It is It still remains the same. This is 4 centimeter. And what is the height of the cuboid? It also remains 4 centimeter. Okay, so now it's a cuboid. Now we have to find the total surface area of this cuboid. That is, we know the formula. It is LB plus BH plus HL. Okay, actually we don't need to remember this formula. Okay, why we don't have to remember this formula? Because we know the formula for a rectangle. What is the area of a rectangle? It is length into breadth. Okay, so if I make any specific surface, okay, now 3 surfaces are seen, 3 faces are seen, 3 faces are not seen. Okay, what is this face? This is length, this is breadth, and this is height. Now, what is the area for this? It is length into breadth. Now, similarly, because one face of length into breadth is not seen, it is at the bottom. So it is length into breadth plus length into breadth. That means 2 times length into breadth. Then this is height into length. This is height into length. And similarly for the other side, which is not visible here, which is not visible. This side, which is not visible to us, it is on the back side of it. It is also height into length. Similarly, this side is breadth into height. And this side is also breadth into height, which is not visible. I'll just say it like this. This part, which is not visible. This part, which is not visible to us. Okay. Now, and if we add that, it becomes 2 times LB plus BH plus HL. Okay, this formula, we don't have to remember it because we know the formula for a rectangle. Okay, now let's just put the values. It is L into B. L into B is 8 into 4. 8 4s are 32. Plus B into H. B into H is 4 into 4, 16. Plus H into L, it's 4 into 8 is 32. Okay, so it becomes 32 plus 32, 64. 64 plus 16. 64 plus 16 comes out to be 80. 80 into 2 is 160 centimeter square. Okay, so let's move to next question. A vessel is the form of a hollow. Oh, the figure is not given. The vessel in the form of a hollow hemisphere mounted by a hollow cylinder. So hollow hemisphere. So I'll just say hollow hemisphere is like hemisphere. This is an hemisphere mounted by a hollow cylinder. Okay, it's mounted by a hollow cylinder. So I'll just say this is a cylinder here. This is a cylinder here. This is a cylinder. It's mounted by a hollow cylinder. Okay. The diameter of the hemisphere is 14. So if the diameter is 14, the radius is 7. Radius is 7. And the total height of the vessel is 13. If total height of the vessel is 17, so if this is 7, what is left? What is the height from the center? The height of the hemisphere, sorry, height of the cylinder comes out to be 13 minus 7, because this complete is 13. This is 13. From here to here, it is 13. So the height of this part will be 13 minus 7. 13 minus 7 is 6. So the height of cylinder is 6. Now find the inner surface area of the vessel. We have to find the inner surface area of the vessel. Now inner surface area will contain the lateral surface area of the cylinder. The lateral surface area of the cylinder, what is that? The lateral surface area is 2 pi RH. So this is the lateral surface area of the cylinder, plus we need to find the lateral surface area of the hemisphere, that is 2 pi r square. And luckily the radius is same for both, so we can take 2 pi r common. It becomes h plus r. Let's put the values. It is 2 into 22 by 7 into radius is 7, and h, height is 6, plus r is 7. So 7 cancels out with 7. It becomes 44 into 7 plus 6, 13. So 44 into 13 is the answer. And that comes out to be 572 centimeter square. I believe this question is clear. In case you're finding any doubts in the question, or in case I'm doing something wrong, please write in the comments so that I'll be able to correct myself. And in case you have any queries, please write in the comments so that I can clarify that. It should be a win-win situation when you're watching this video. Okay, coming to the next question. A toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of the same radius. Okay, it's a cone. I'll just write mounted on a hemisphere. So I'll just first make a hemisphere. A toy is in the form of a cone of radius itna mounted on a hemisphere. So let's make a hemisphere. This is a hemisphere, and on top of it there is a cone. This is a cone which is made. Okay, this is the kind of shape of. Okay, the shape is not given, so the shape we have to make. Of same radius. The total height of the toy is 15.5. So from here, from top to bottom, is 15.5. Is the total height of the toy. They have already given to the cone of radius 3.5. So that means this distance is 3.5. 3.5. That means this distance is also 3.5. If this is the distance 3.5, what is the length of? What is the height? The height of this is 15.5 minus 3.5. So 15.5 minus 3.5 is this distance is 15.5 minus 3.5 comes as 12. Okay, 12.0. So this is 12. The height comes out to be 12. Now, find the total surface area of the toy. So we need to find the total surface area. So the total surface area of toy is equal to, first we need to take the cone. The cone is pi RL. That's the lateral surface area of the cone plus the total surface area or the lateral surface area of the hemisphere. So it is 2 pi r square. Okay, now what is common here? This is pi r is common. It comes as L plus 2r. L plus 2r. But do we know L? L. We don't know L. So first we have to find L. So how to find L? L is equal to the square root of 12 square plus 3.5 square. So when it says 12 square is 144 plus 3.5 square is 3. 4 is 12. It comes as 12.25. So it comes as 0.25 and 4 plus 2, 6. 4 plus 1, 5. 156.25. So the value of L is it comes out to be 12.5. So the L is 12 is equal to 12.5. This is the lateral. This is the lateral height is 12.5. Good. Now we have all the information, so we can just write. It is as 22 by 7 for pi. Radius is given as 3.5. L is 12.5 plus 2 times r. 2 times r is 2 into 3.5. So if I say 3.5, 2 times 2, 11 times. So it comes as 11 multiplied by 12.5 plus 7. So it is 11 multiplied by 19.5. So they have given simple calculations here so that you people do not have to struggle much. It is 214.5 centimeter square. So this is the answer. Okay, coming to the next question. It says a cubical block of side 7 centimeter is surmounted by a hemisphere. A cubical block. I'll just make a cubical block. It's a cube. This is a cubical block. Okay, not exactly cube, but yeah. This is something behind. And it is surmounted by a hemisphere. So there is a hemisphere. Is a figure given? No, figure is not given. So this is a hemisphere at the top. I'll just write it as this is a hemisphere. Like this. This is round. It's a hemisphere. At this point, I just write this. Okay, this is a hemisphere on the top. With the greatest diameter. With the greatest diameter means it is 7 centimeter. The diameter will be 7 centimeter. This is 7 centimeter. Okay, so it is like on the top is 7 centimeter is the diameter. So we know the diameter for this hemisphere can have. Find the total surface area of the solid. Now, if you have to find the total surface area, we know that the total surface area of the shape, okay, shape is equal to. So first we'll find the total surface area of the cube. Okay, the total surface area of the cube comes out to be 6a square. Okay, when a is the side. But this part, this part, okay, it is inside. It is inside. So we have to reduce the surface area for this. We need to reduce the surface area for this. That means we have to reduce pi r square from this. Okay. Plus, we need to add these surface area, the curved surface area of the hemisphere. So that is equal to 2 pi r square. Okay, so it comes out to be 6a square plus pi r square. Is 2 pi r square minus pi r square is pi r square. So let's compute it. It is 6 into a is 7 into 7 plus pi is 22 by 7 into a is r square. Radius is 3.5. So it is 3.5 into 3.5. So 3.5 2s are 2, 11s are. So it comes as 7 6 are 42. 42 into 7. 42 into 7 comes out to be 294 plus 3. It comes as 38.5. So plus 38.5, it comes out to be 332.5 centimeter square. So this is the area of the picture. Okay. So coming to the next question. Okay. So this question states that a hemispherical depression is cut out of one face of the cubical wooden block such that the diameter L of the hemisphere is equal to the edge of the cube. Okay. Diameter of the surface area of the remaining determine the surface area of the remaining solid. So we need to find the surface area here. So let's first draw it. Okay, how exactly it's going to look like. So this is a cubical piece. This lines might not be straight, but yeah, it's a cubical piece. And here, so a sphere is dug here. Basically, it's down. It's okay. It's kind of the sphere is dug out here. Okay, and the diameter of this circle is L. So you can say that the diameter is L. So the radius of sphere is equal to L by 2, and uh, length of cube or length or basically edge of cube, length or edge of cube is equal to L. Okay. Now we need to find the total surface area. For total surface area, we need to find the total surface area of the cube minus this area, because at this place, if you look from the top, it is a square shape where a circle is dug out, which is touching all four sides. It's touching all four sides. So it is dug out, and a sphere is made inside. Okay, the sphere is, I should not make this. A sphere is made here. Okay, so we need to reduce the area of this circle from, we need to reduce the area of the circle from the total surface area of the cube. So total surface area of this picture, total surface area of this shape is equal to, so the total surface area of the cube, that is 6 into L square, 6L square minus it's pi r square, that is pi into the radius of this circle is L by 2. So we'll say L by 2 square. Okay. Plus there is a sphere, the hemisphere, which is, it's a hemisphere which is dug out. When the hemisphere is dug out, that means we have to take the surface area of the hemisphere also. Okay, so that is 2 pi r square. R is what? L by 2 square. Okay, so it comes out to be 6L square, 2 pi L by 2 square minus pi L by 2 square. It comes out to be plus pi L by 2 square. Okay, so we can take, if I take the LCM of it, it comes out to be 4. Okay, so it becomes 24L square plus it is pi L square, or if we take L square as common, it becomes 24 plus pi divided by 4. So this is the answer which has come up. So we have taken in terms of pi. Okay, and we have kept L square as L square. So to L square, 24 plus pi divided by 4. And this will be in centimeter square or meter square or something. Okay, we have not mentioned uh, the unit here. So it should be centimeter square or meter square. Okay, so coming to the next question now. It says a medicine capsule is in the shape of a cylinder. So this is a cylindrical shape. Let's see if I just make it like this. This is a cylindrical shape. Okay, it's a round shape. It is not a rectangle. It's a round shape. Okay, with two hemispheres stuck to each of its ends. So this is one hemisphere, and this is another hemisphere which is stuck to its ends. The length of the entire capsule is 14 millimeter. So this entire is 14 millimeter, which is given. And the diameter of the capsule is 5 millimeter. The diameter is 5 millimeter. Find its surface area. Okay, so the total surface area of this capsule is equal to the lateral surface area of cylinder. Lateral surface area of cylinder, because we have to take the lateral surface area. Okay, we don't have to take the flat surface area of the cylinder, only the lateral surface area. Plus, we need to take for this hemisphere and this hemisphere. Okay, plus curved surface area of hemisphere plus curved surface area of hemisphere. So if I have to find out lateral surface area of cylinder, I'll say it is 2 by radius. What is the radius here? It is 5 by 2 millimeter. Okay, this complete is 5. This distance complete is 5. So the radius comes out to be 5 by 2. So I can say 2 pi RH. Okay, I'll just taking R as, I'll just mention the radius is equal to 5 by 2 millimeter, or you can say 2.5 millimeter. Okay, so I'll erase it. So it is 2 pi RH. So instead of R, I'm writing 2.5 into H. Okay, what is the length of the cylinder? See, if it is 14, how much is this part? So it is 14 minus 2.5 this side and 2.5 this side, minus 2.5. So this is 14 minus 5. What is 14 minus 5? This is 9 millimeter. So I'll take it as L. It's 9 plus curved surface area of hemisphere. So it is 2 pi R square. What is R? 2.5. So it is 2.5 into 2.5 plus 2 times 2 pi, 2.5 into 2.5. It's the same, both sides. Okay, if you see this 2 pi, 2.5, 2 pi, 2.5, 2 pi, 2.5 is common. So it is say 2 pi or 2.5 into 2, I can say 5 pi is common. So I'll just clear it up. I'll just say 5 pi is common across. So when 5 pi is common, this complete piece is gone from here. It is left is 9. Now 5 pi, this complete piece is gone from here. It becomes 2.5 and plus 2.5. So it becomes 5 pi into 9 plus 5. 9 plus 5 is 14. So it becomes 14 pi is a 70 pi. So if I take it as 22 by 7 into 22 by 7, it is 7 into 10, it comes as 220 millimeter square. This is the area of this is the total surface area of the capsule. Okay, the calculation was pretty easy. So, and please remember, okay, to write the unit. I'm telling it multiple times. Please remember to write the unit. If you don't write the unit, you want to miss out marks. Okay, come on. Coming to the next question. A tent is in the shape of a cylinder surmounted by a conical top. Cylinder surmounted by a conical top. Is the figure given? No, figure is not given. So I'll just make a cylinder. This is a cylinder and it is surmounted by a conical top. Let's make a cone out here. Okay, it's a nice hut. Okay, if the height and the diameter of the cylinder are part of 2.1 meter and 4 meter respectively. If the height and the diameter of the cylindrical part, so we are taking only the cylindrical part here. The height is 2.1 and diameter is 4 meter. So everything is in meter. So radius comes out to be 2 meters. If the diameter is 4 meter, the radius will be 2 meters respectively. And the slant height of the top is 2.8 meters. Oh, good. They have already given slant height is 2.8 meter. If the height and diameter of the cylindrical part, okay, cylindrical part they have given, as well as they have given the slant height of the top is 2.8. Find the area of the canvas used for making the tent. Okay. Also, find the cost of the canvas for the tent at the rate of 500 per meter square. Note that the base of the tent will not be covered with canvas. Okay. So what will be covered with canvas? Okay. The curved surface area. What should be? Okay. The total surface area of tent is equal to, we have to take curved surface area of cylinder. Why only curved surface area? Because the base will not be covered. The top will any which ways will not be covered because top is part of the tent, inside the tent, and moreover it doesn't come as the as a surface of the tent. Okay, base, we don't have a tent at base. They've already mentioned it. So base is not covered and this part is not covered. So it is the curved surface area of the cylinder. Plus, we have to take the curved surface area of the cone. That is curved surface area of cone. So if I take it as curved surface area of cylinder is 2 pi RH. It is 2 pi R into H plus curved surface area of cone is pi R L. Luckily, they have given L here. Okay, what is common in this? Pi is common in both. Pi and R, both are common. So it becomes 2H plus L. Now, let's compute it. Pi, we'll take it as 22 by 7. Radius is coming out to be 2. Radius coming out to be 2. Then 2 times height. So this is the height of the cylinder. So 2 times height is 2 into 2.1. So 2 into 2.1 plus L. L is 2.8. So it comes as 22 by 7 into 2. This is 4.1. 4.2, sorry, 4.2 plus 2.8. 4.2 plus 2.8 comes out to be 4, 5, 6, 7. So it comes out to be 22 by 7 into 2 into 7. So 7 will cancel out with 7. It comes out to be 44. It comes out to be 44 square meter. 44 meter square. Now they want to know what will be the cost of making this. The cost of making this will be the cost of making it is equal to 44 multiplied by 500. Okay, so 44 paisa, it is comes out to be 220 and 2 zeros. So it is 22,000 rupees. The cost is 22,000 rupees. Okay, so good thing is that the calculation was not that long. Good. Coming to the next question. From a solid cylinder whose height is 2.4 meter and diameter is 1.4 centimeter. Okay, centimeter. Both are in centimeter. Sorry, this from a solid cylinder whose height is 2.4 centimeter and diameter 1.4 centimeter, a conical cavity from the same height and same diameter is hollowed out. Okay. Find the total surface area of the remaining solid. The figure is given here. No, the figure is not given here, so we have to make it from a solid cylinder. So let's make a solid cylinder here. This is a solid cylinder. This is a big cylinder out here. Okay, and what they're saying, whose height is 2.4 centimeter. Solid cylinder height is 2.4 centimeter and diameter 1.4 centimeter. If the diameter is 1.4, so I can say the radius comes out to be 0.7 centimeter is the radius. A conical cavity of the same height, a conical cavity, so it's the same height means it's the cone which is dug out inside this. So I'll just take it here and here. So there is a cone which is dug inside it. Okay, dug inside it. And now we have to find the total surface area of the remaining solid. Now for covering this, because this is a solid one, this is a solid. So when we are finding the total surface area for this, what will it include? It will include the total surface area of this shape. What all things it will include? First of all, because it is curved out, so this will not include because it's already a hole. This part is already a hole, so this will not include that hole. So it will cover the curved surface area of cylinder. This is curved cylinder plus the base. The base will be covered because base is still solid. That's the still part, remaining solid. Okay, so base will be covered. So I'll just say it is pi r square. Base is pi r square. That will be covered plus the lateral surface area that is pi r L. The lateral surface area of cone. I'll just say lateral or a curved surface area of cone. Curved surface area of cone. So these are the three things which you have to take. So for finding pi r L, we need to first find L. So how will you find L? So if we make a height here and radius here. So now we have, this is 2.4 centimeter and this is 0.7 centimeter. So we need to find L. So for L is equal to square root of 2.4 square plus 0.7 square. So 2.4 square is 5.76 plus 7 square is 49. So 0.49. Let's find out what L comes out to be. So 5.76. Where is it? Where is it? Where is it? It comes out to be 6 square root of 6.25, and this is, it comes out to be 2.5. This is the square root is 2.5, so there's a 6 point. I just cancel it out. Square root 6.25. So it comes as 2.5. So this lateral length is 2.5. Okay, now we have everything to compute it. The curved surface area of cylinder is 2 pi r h plus it is pi r square, the base, and the pi r l, the curved surface area, is pi into r because radius is same for all. So I can just take an L. Okay. Now what is common across? The pi r is common across. So I'll just take pi r. It becomes 2h plus r plus L. So it is equal to pi. Pi is, I'll take it as 22 by 7. Radius is 0.7. Good. It will cancel out. It is 2 times height. That is 2 into 2.4. 2 into 2.4. So 2 multiplied by 2.4. We'll compute it later. Radius is 0.7 plus it is 2.5. L is 2.5. So it is 0.7 tens are okay. So it has become 22 divided by 10 into is 2.4 into 2 is 4.8 plus 0.7 plus 2.5. So 2.5, let's compute it. 4.8 plus this is 5.5, 5.5, 6.5, 7.5, 8. So it becomes 22 by 10 into 8. Let me just check what's the correct one. It is 4.8 plus 0.7 plus 2.5 comes out to be 8. Now just compute it. For 2 5s are 10. Sorry, 2 4s are 8. 2 5s are 10. What mistakes I'm doing? And that's it. So it becomes 88 divided by 5. 88 divided by 5, 5 1s are 5. 5 7s are 35. And then 30, 5 6 are 30. So it comes out to be 17.6 centimeter square. 17.6 centimeter square. Seems pretty small. Some calculation mistake. Let's check 22 into 8. 22 into 4. 22 into 4 is 88. Good. 88 divided by 5. 17.6 centimeters square. Okay. Let it be. Okay. So coming to the next question. A wooden article. Now the figure is given. That's a good part. A wooden article was made of scooping out a hemisphere from each side of the solid cylinder. Okay. This time they have dug out from both the sides. If the height of the cylinder is 10 centimeter, height of the cylinder is already given, and the base of the radius is 3.5. So basically, both the sides, the radius is 3.5. Here also it is 3.5. Find the total surface area of the article. You have to find the total surface area. So what is the total surface area of the article is equal to? It is the lateral surface area of cylinder, the lateral surface area, because this complete part, okay, which is the lateral surface area, plus 2 times curved surface area of the hemisphere. So the lateral surface area of cylinder, we know it is 2 pi r into h plus 2 times the curved surface area. It is 2 into 2 pi r square is 2 pi r square. Okay, let's find out. 2 pi r is common across. So we'll just say 2 pi r common. It becomes h plus this h here. And 2 pi r we have common. So it becomes 2r. So let's put the values now. It is 2 into 22 by 7. And the radius is given as 3.5. H height was 10 centimeters. Plus 2 times r is 7. 2 times r is 7. Okay, so I'll say 3.5. 2s are and 2 will cancel out. So it comes as 22 multiplied by 17. So it is again a simple calculation. The good part is they want to, CBSE people, they want you to understand the concept and how it is getting computed. And they don't want you to struggle on finding out how to do it. They don't want to check your multiplication skills. Okay, they want to check whether you understand the concept or not. That's why they give easy multiplications in these kind of questions. So it's 374 centimeter square. This is the answer. 22 into 70 is 374 centimeter square. Okay, so coming to the next question here. Okay, it is Shanta runs an industry in the shed, which is in the shape of a cuboid surmounted by a half cylinder. Okay, half cylinder is there. So this is the half cylinder. This part is the half cylinder, this complete one. Okay, if the base of the shed is a dimension of 7 meter and 15 meter. Okay, this 7 meter, the base of the shed is of the dimension 7 meter by, okay, this is 7 meter by 15 meter. This is the base. So it is 7 meter here and 15 meter here. And the height of the cuboid portion is 8. Find the volume of the air the shed can hold. This is the volume. That is one first question. Further, suppose the machinery in the shed occupies a total space of 300 meter cube and there are 20 workers, each of whom occupy about 0.08 meter cube space on an average. Then how much air is in the shed? Okay, so we have to find two things. First of all, we have to find the volume of it, and then we have to find out how much air is inside after reducing the volume of the men in this area. Because they say further, suppose the machinery is this much, so we have to reduce this part, and we have to reduce the volume of the workers. Okay, so it's a total volume. Okay, total volume is equal to, it is volume of cube, volume of cuboid. Volume of cuboid. So there's a cuboid plus half volume of cylinder. So this is the total volume of the shed. Now, what is volume of cuboid? It is length into breadth into height. So length comes out to be 15, width comes out to be 7, and height comes out to be 8 plus half. Okay, the volume of cylinder is pi r square h. Say pi r square h. So I'll just take this 22 by 7 pi. What is the radius of it? So when it is given as 7 meter, this is 7 meters. So that means the radius of it is 3.5 meters. The radius is 3.5 meters. So I'll just take radius as radius is equal to 3.5. So this is 3.5 as radius. Okay. So this is 3.5 into 3.5. And what is the height of it? What is the height of it? So this will be considered as the height of the cylinder. That is 15 is the height of the cylinder. Okay, so let's compute it. 3.5 twos are 2 11s are, and this comes out to be, let's compute it now. Okay, this 15 into 56 plus 11 into 3.5 into 15 divided by 2. This time they have given a lot of computation, but not much. Okay, in points. Let us compute it. So it is 56 multiplied by 15 gives us 840 plus 3.5 multiplied by 15 multiplied by 11 divided by 2. It gives us 288.75. And if I add it with 840, it becomes 1128.75. So this is the total volume. So it is this much meter cube. This much meter cube. So volume is always measured in meter cube. Now we need to subtract 300 meter cube. The second part. So this part is done. Now second part is, then how much is air in the shed? So for finding total air is equal to total volume minus volume of machinery minus volume of men inside it. Okay, so it is 1128.75 minus volume of machinery is 300. They have already given it. Minus, now there are 20 workers. So it is 20 multiplied by 0.08. Okay. I'll just check here. I'm just still seeing that why it is not half volume of cylinder. Half pi r square h pi r square into h. So we cut it to 3.5 twos are and 2 11. So 11 into 3.5, 11 into 3.5 into 15 divided by 2. Okay, we have taken it correctly. So it comes out to be 20 into 8 is 120 into 0.08 comes out to be 1.6. So it is 1.6, 1128.75 minus 301.6. 827.15 meter cube of air. So this comes out to be the answer. Okay, guys. Okay, so coming to the next question here. A juice seller. What is he doing now? A juice seller was serving his customer using glasses as shown in the figure this much. There is a figure which is given. The inner diameter of the cylinder glass was 5 centimeter. Okay, this is 5 centimeter. Or you can say this is, sorry, it's the diameter, right? The inner diameter. So this is 2.5. 2.5. This is 2.5. 2.5 centimeter. But the bottom of the glass has a hemispherical raised portion. Okay, they have raised something hemispherical to show that I am giving more juice. Raised portion which reduce the capacity of the glass. So basically he's serving less juice but showing that I am giving a full glass. If the height of the glass was 10 centimeter, this is 10 centimeter here. Okay, find the apparent capacity of the glass and its actual capacity. Okay, so first we need to find the actual capacity. What is actual capacity? See, if there is no spherical thing inside, if there is no spherical shape or this fill up inside, the capacity would have been capacity without hemispherical fill up is equal to pi r square h. Let's see, volume of cylinder. So you can say is 22 by 7. They have asked to take us 3.14, so we'll take it as 3.14. It comes out to be 3.14 into r square. Our radius is 2.5 into 2.5 into height is 10. So it comes out to be, because 3.14 and 25 into 25 is 6.25. 6.25 into 10 is 62.5. Okay, so 62.5 multiplied by 3.14 comes out to be 196.25. 196.25 centimeter cube. So this is the capacity of the glass. This is the actual capacity of the glass. But from this actual capacity, what has happened? They have filled this hemisphere, right? When they have filled this hemisphere, that means the volume of this hemisphere will be reduced from it. The volume of this hemisphere will reduce from it. So what is the volume of a hemisphere? So volume of hemisphere is equal to, it is 2 by 3 pi r cube. 4 by 2 by 3 pi r cube. So this is the volume of hemisphere. So let's compute it. It's 2 by 3 into 3.14 into r cube. R cube is 2.5 into 2.5 into 2.5. So let's find out what it comes out to be. Oh God, man. Though it is not that difficult, but computation is required. So it comes out to be 32.71 centimeter cube. So this is the volume which is reduced. So if we take the actual capacity, basically how much. So this is something which is showing that he is giving, but actually not giving. Okay, so actual capacity is equal to 196.25 minus 32.71 comes out to be 163.54 centimeter cube. This is the capacity comes out of it. Okay, so coming to the next question here. A solid toy is in the form of a hemisphere. Okay, it's already given. This is a solid toy surmounted by a circular cone. Okay, it's a hemisphere. This is the hemisphere. This is the hemisphere surmounted by a cone here. Cone. The height of the cone is 2 centimeter. The height of the cone is 2 centimeter. This is the height of the cone. This, I'll just make it separately. The figure is, this is a hemisphere and there is a cone. The height of the cone is 2 centimeter. This is 2 centimeter. Okay, then, and the diameter of the base is 4 centimeter. The diameter of the base, that means the radius is also 2 centimeter. Determine the volume of the toy. If the right circular cylinder, if the right circular, okay, that's his first question. Determine the volume of the toy. This is first question. Then comes, if the right circular cylinder circumscribes the toy, find the difference of the volume of the cylinder in the toy. Okay, so there is a cylinder. Okay, let's find the first thing first. First, we determine the volume of the toy. So volume of toy is equal to volume of hemisphere. It is volume of hemisphere plus volume of cone. Okay, so volume of hemisphere is 2 by 3 pi r cube plus volume of cone is 1 by 3 pi r square h. So let's find out what is common in between these, because the radius is same. So we can say 1 by 3 pi r square is common. So it becomes 2r plus h. 2r plus h. So let's find the answer. 1 by 3 into pi, I'll just take it as 3.14 into radius square. Radius is 2. So 2 into 2, 4. That is 2 times radius is 2 into 2 is 4 plus height. Okay, this height is for the, okay, this height is the same, 2 centimeters. So height is also 2. So it becomes 1 by 3 into 3.14 into 4 into 6. So 3 2s are 6. So it is 3.14 into 8. 3.14 into 8. So that comes out to be 25.12. Okay, this is centimeter cube. So this is the volume of the toy. Now we need to find the difference in the volume of the cylinder in the toy. Okay, so if I completely merge it, okay, first we need to find the volume of the cylinder. Volume of cylinder. So we'll find volume of cylinder and we'll subtract the volume of the toy from it to get the rest of the volume. So volume of cylinder is equal to pi r square h. This is pi r square into h, and everything is 2. So we can take it as 3.14 into r square. R is 2 into height is also, no, height is not 2 here. Height for this is 4. Height for this is 4 centimeter. We have to remember this. Height for this is 4 centimeter. Earlier it was 2 and 2. So height for this is 4 centimeter. So it comes out to be 3.14 into 4 to the 8 to the 16. Oh, we could have computed it easily. We unnecessarily made it difficult. So it will come out as, see, it's double of it actually, because this is 3.14 into 8, this is 3.14 into 16. Okay, so if we subtract it, so I'll just leave it like this. It's 25, 50, 50.24. This comes out to be 50.24. Okay, now the difference is equal to 50.24 minus 25.12. It comes out to be 25.12 centimeter cube. Isn't it? Okay, this is a pretty easy question. So let's come to the exercise now. Exercise 12.2. A solid is in the shape of a cone standing on a hemisphere. Okay, cone. The figure is given. No, figure is not there. A solid is in the shape of a cone standing on a hemisphere. So this is a hemisphere. surmounted by a cone. Cone standing on a hemisphere with both their radii being equal. So radius is equal. So this radius is same. So this radius is equal to 1 centimeter, is 1. And the height of the cone is equal to its radius. Okay, height of the cone is equal to its radius. So this is also 1. Is find the volume of the solid in terms of pi. Okay, so volume of this toy or volume of this figure of this item is equal to volume of hemisphere plus volume of cone. My writing has become so bad. Volume of hemisphere. What is volume of hemisphere? It is 2 by 3 pi r cube. And what is the volume of cone? The volume of cone is 1 by 3 pi r square into h. Now the value of r is equal to 1, r is equal to 1, h is equal to 1. Let's put the value. So it comes out to be 2 by 3 into pi, and its 1 cube is 1, plus 1 by 3 pi, and this is r is 1. So it's 1 to 1 into 1. Basically everything is 1. So this comes out to be 1. So now it is 2 by 3 pi plus 1 by 3 pi. So it is 2 by 3 plus 1 by 3 is 3 by 3 pi. So the answer comes out to be pi centimeter cube. Good question. Very good question. Very good answer. Pi centimeter cube is the answer for it. Next. Okay. So Rachel, an engineering student, was asked to make a model shaped like a cylinder, and two cons figure is not given. Okay. An engineering student was asked to make a model shaped like a cylinder with two cones attached to its two ends by using a thin aluminum sheet. Okay, so there are two cones attached on both the sides. Okay, some cylinder is there, so I just make a cylinder here. So this is a cylinder like this. So this is a cylinder, and they are saying both the sides cone is made here. This one cone, and this is another cone. Okay, I believe this is the figure, and this is made of aluminum sheet. Two cones attached to its ends by using the thin aluminum sheet. The diameter of the model is 3 centimeter. The diameter of the model is 3 centimeters. So this is 1.5 centimeter. I just say 1.5 centimeter is the radius. So radius is equal to 1.5 centimeter, and its length is 12 centimeter. The diameter of the model is 3 centimeter and its length is 12 centimeter. The length of the entire thing is 12 centimeter. If the length is 12 centimeter, we need to find out. We have to, okay. If each cone has a height of 2 centimeter, the height is 2 centimeter. This is 2. This is 2 centimeter. This side also it is 2 centimeter. So what is the length here? It is 12 minus 2 comes out to be, this comes out to be 12 minus 2 comes as 8 centimeter. The cylinder has the length of 8 centimeter. Find the volume of air conditioned, volume of the air contained, not conditioned, air contained in the model that Rachel made. Assume that the outer and inner dimensions of the model to be nearly the same. Okay, so if it's very thin, so we are considering the outer and inner dimensions are exactly the same. So we need to find the total volume of the shape, total volume, total. I just clear it up. Writing very badly, so I should write slowly for you to understand. Total volume of this shape. Total volume of the shape is equal to volume of cylinder plus volume of 2 times volume of cone, because there are two cones attached. Okay, so let's put the values. So volume of cylinder is pi r square h. This pi r square into h. And the volume of cone is 2 times the radius is same, so we can say volume cone is 1 by 3 pi r square into h. Okay, the h is different. Okay, h1 I'll just take h dash. So what is common? Because pi r square is same for both, so I can take pi r square as common. It comes as h, height, plus it comes as 2 by 3. So 2 by 3 is left, pi is gone, I square is gone, into h dash. Now let's put the value. It is pi. We'll take it as 22 by 7. Will it make any difference? Or we should take 3.14. Okay. Radius. Now radius is same. Radius is same. It is 1.5 centimeters. So it's a 1.5 into 1.5. Now pi r square h. This is the height. Height of the cylinder. That is 8 centimeters. Plus 2 by 3. Height of the cone. That is 2 centimeter. Okay. So let's compute it. It's just 3.14 into 1.5 into 1.5 square is 2.25. This comes as 2.25. Now 8 plus 4 by 3. 8 plus 4 by 3. So if I add it, it comes out to be 25 into 8 3 is 24 plus 4 by 3 to 24 plus 4 is 28. So instead of 3.14, I'll just take it as 22 by 7. So instead of this, I'm just taking 22 by 7. So this value comes out to be 22 by 7 multiplied by 2.25 multiplied by, because it's come as 28. Okay, that's why I have taken it as 7, because it will cut. It will cut. So it is 7 4s are 28. So simple. Now 3.3 7s are 21 and 3 5s are 15. Wow. So it comes out to be 22 multiplied 0.75 into 4 comes out to be 3. Right? So it is simple calculation. 66 centimeter. We are finding the volume, centimeter cube. So 66 centimeter cube is the good part. Is the computation is simple. The computation here is simple. So everything comes out to be either cutting or basically we could do it manually. Okay, we don't have to use too much of multiplication and things in this. Okay, so answer comes at 66 centimeter cube. Let's come to the next question. गुलाब जामुन, अरे मुंह में पानी आ गया भाई. एक गुलाब जामुन मिलेगा क्या? No. Okay. A gulab jamun contains sugar syrup up to 30% of its volume. 30% उसमें juicy gulab jamun है. Find approximately how much syrup would be found in 45 gulab jamuns. Oh, the figure is also not given here. 45 gulab jamuns, each shaped like a cylinder with 2 hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. Oh my goodness, मैं तो जामुन की याद दिला रहे हैं फिर. Let's make a gulab jamun. How they made it? It's a cylindrical gulab jamun, and both side is hemisphere. This side is also hemisphere. Okay, so this is hemisphere and this is hemisphere. Okay, now we should first find the volume of it. Now, how will you find the volume of it? Find approximately how much syrup it would contain. 45 gulab jamuns, each shaped like a cylinder with 2 hemispherical ends with length 5 centimeter. What is the length? Cylinder with 2 hemispherical ends with length 5 centimeter. The length of the gulab jamun is 5 centimeter. This is the length of the gulab jamun. And the diameter is 2.8. That means the radius is 1.4 centimeter. Okay. Now, if the complete length is 5 centimeter, and this is 1.4 and this is 1.4 subtracted from it. So what is this length? It is 5 minus 1.4 minus 1.4. So it becomes 5 minus 2.8. So it comes out to be 2.2 centimeter. So this is 2.2 centimeter from here to here. Okay, now we have to find the volume of it. What is the total volume? So volume of one gulab jamun, J, okay, one gulab jamun is equal to volume of cylinder, volume of cylinder plus 2 times volume of hemisphere. Okay, so what is volume of cylinder? The volume of cylinder comes out to be, it is pi r square h. Okay, the h is different here. Plus the volume of the hemisphere, it is 2 multiplied by, what is volume of hemisphere? It is 2 by 3 pi r cube. So let's find out, because the radius is same, we can take pi r square as common. So it comes as pi r square is common. It becomes h plus, so pi r square is gone. It becomes 4 by 3 into 1 radius. Now putting the value, I'll just take 22 by 7. I believe it will cut. Radius is 1.4. I'll just say 1.4 into 1.4. Yes, it will cut. What is the height? This is the height of the gulab jamun's cylinder part. Okay, that is 2.2. It is right as 2.2 plus 4 divided by 3. And what the radius? Radius comes out to be 1.4. This is what you'd find. So we can say 7 into 0.2. 7 into 0.2. And this 22 into 2.2 comes out to be 4.4 into 1.4. So let's try to compute it manually. 14 fours are 52. So it is 2.2 plus 5.14 fours are 56, 5.6. How am I making mistakes? Divided by 3. So it comes out to be 4.4 into 1.4. It comes out to be 6.6 plus 5.6 divided by 3. So let's find out. That is 6 plus 6, 12. 6 plus 6, 12. 1 carry. So it becomes 6 plus 6, 12. So it is 1, 2, 2. This is 12.2. 12.2. I believe so. I'm correct. 5 plus 6, 11. Yeah, 12.2. And divided by 3. There was no pi. Okay. Multiplied by 4.4 and 1.4. 4.4 and 1.4. Nothing is cut there. I was thinking something will cut, but it's not cutting. Let's find out then. Or we have made some mistake. But they generally don't give this kind of thing. Let's find out. 12.2 multiplied by 4.4 multiplied by 1.4 and divided by 3 comes out to be somewhere around 25. This is 25. Oh, I forgot that we have to multiply it with 45 gulab jamun. So if I multiply this, the total, okay, this is for 1 gulab jamun. 1 gulab jamun, okay. I have to multiply it with 45. So I'll just take 45 also. So when I multiply it 45, this becomes 315 times. Okay, so now everything is cut. Now the answer should come unique answer. It is not something. So they gave an easy question. We made it difficult. It is 15 multiplied by 12.2 multiplied by 4.4 multiplied by 1.4. So answer comes out to be 1127. Let's cancel 1127.28. Okay, so this is the answer. This is, I have to mention how much it is centimeter cube. We should remember. This is the volume of 45 gulab jamuns. खाने को तो मिले नहीं. Okay, so coming to the next question. It says a pen stand made of wood. Okay, this is made of wood in the shape of a cuboid Okay, this is made of a cuboid. Okay, with 4 conical depressions to hold press. So this is a cuboid. Okay, this is cuboid, and there are 4 depressions. This is the depression. Depression to hold pens. There are 4 pens it can hold. The dimension of the cuboid are 15 centimeter, 10 centimeter, and 3.5 centimeter. Okay, the radius of each depression is 0.5 centimeter. The depression is also 0.5 centimeter deep, and the depth is the depression. I'll just make a this depression. The radius of this depression, radius of depression. So I just make it a big cube. Okay, I'm making the depression a little big because it is conical shape. I'll just make it big so that we don't make mistakes here. They're saying radius is equal to 0.5 and the depth is 1.4. Depth is 1.4. The height is 1.4 here, 1.4 centimeter. Okay, find the volume of the wood in the entire set. So volume of the wood. What is volume of the wood required? Volume of wood is equal to, so we need to first find the total the volume of the entire cuboid. So it is volume of cuboid minus 4 times, because there are 4 conical depressions in it. So 4 times volume of cone depressions. Cone depressions. Cone depressions. So what is volume of cuboid? The volume of cuboid comes out to be length into breadth into height. And we know it is 15 by 10 by 3.5. So this is 15 into 10 into 3.5 minus 4 times volume of cone. What is volume of one cone? Is 1 by 3. 1 by 3 into pi. Pi is, I take it as 22 by 7. R square h. So what is R? It is 0.5 into 0.5 and height comes out to be 1.4. Simple computation. Let's do it. How to do it is 3. 3 is not cutting anywhere. We have to do it still. So 15 tens of 150, 150 into 3.5. 150 into 3.5. Comes out to be 525 minus. Now I can cut 7, 0.2 times. 0.2 times 1.4. Now it is compute the entire thing. It is 22 divided by 3 multiplied by 0.5 multiplied by 0.5 I'll just cancel out. I'll just say first 0.5 multiplied by 0.5 multiplied by 0.2 multiplied by 22 divided by 3 is equal to into 4. It comes as 1.47 approximately. And if I subtract 525 from it, basically if I subtract the other way around, it comes out to be 523.53 centimeter cube. This is the total wood required for making this, or basically this is the volume of the wood, 523.53 centimeter cube. Good question. Coming to the next question. A vessel is in the form of an inverted cone. The figure is again not given. A vessel is in the form of an inverted cone. Okay, inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. How can the cone be open? A vessel is in the form of an inverted cone. Inverted cone. So if I say, okay, I'll just take this. This is a cone. Okay, this is a vessel in the cone. Its height is 8 centimeter. let's say its height is 8 centimeters. Okay, that's fine. 8 centimeter. And the radius of its top, which is open, is 5 centimeter. Okay, this is 5 centimeter, this cone. 5 centimeter. It is filled with water up to the brim. Okay, it is filled with water. When lead shots, each of which is a sphere of radius 0.5 centimeter, were dropped into the vessel. So some lead shots were dropped in it. These are lead shots. Some dropped in it. The vessel, 1/4 of the water flows out. 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Okay. So the question is, how many such lead shots have been put in the water? So understand this part, that the total volume of this cone, total volume of this cone, I'll say total volume of I'll just write it clearly. Okay. So what they want to say is that 1/4 the volume of cone is equal to volume of lead shots. Lead shots. Okay. So volume of lead shots. So I'll say 1/4 the volume of cone. What is the volume of cone? It is 1/3 into pi r square. It is 5 into 5 into height. Height is 8. So this is the 1/4 of the volume of the cone. That should be equal to n number of shots. So this will say n number of shots. I don't know how much. So we have to find the value of n. Okay. Into it is spherical. Things are spherical. So what is the volume of a sphere? It is 4/3 into pi into r cube. R cube is, they are saying the radius is 0.5. That means into 0.5 into 0.5 into 0.5. So pi will cancel out. I'm so happy that the pi cancels out. This 3 will also cancel out. I'm so happy this is cancel out. This is 4 into 2. Okay. Now, what is the value of n? So if I just take n is equal to, it is 5 into 5 into 2 divided by 0.5 into 0.5 into 0.5 into 4. This is something which you have to find out. So 0.5, if I just say 0.5, tens are 0.5, tens are 5, 2, 2s are 4, 0.5, how many times? It's 2 times is 1, it's 20 times is this one, and 2 tens are, so it comes out to be 100 spheres. 100 spheres. They have put 100 spheres to take out 1/4 of this volume. To take 1/4 of this volume. Okay. The computation is also easy. Good. This kind of questions I like when the computation is less. Okay. Again, the figure is not given. A solid iron pole consists of a cylinder of height 220 centimeter. Iron pole consists of a cylinder of height 220 centimeter and the base diameter of 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole given that 1 centimeter cube of iron was approximately 8 gram of mass. Okay. A solid iron pole consists of a cylinder of height itna and base diameter this much, which is surmounted by another cylinder of 60 centimeter radius. Okay, there is a cylinder here. There is a cylinder here of height 220 centimeter. Height is 220 centimeter. And the base diameter is 24 centimeter. The diameter is, so I can say it is 12 centimeter radius. 12 centimeter radius, which is surmounted by another cylinder of height 60 centimeter. So there is another cylinder on it. On top of it, this, I can say here it is, another cylinder is kept here, and the height of the cylinder is 60 centimeter, and the radius is 8. So the radius for this is 8. I made it very small, but this is radius is 8. Find the mass of the pole. We have to find the mass of the pole. Okay. So when we have to find the mass of the pole, for that, first of all, we should find the volume. See, volume multiplied 1 centimeter cube has 8 grams. So first we'll find the volume, and with the volume, when we multiply it with 8 grams, it will give us the mass. Okay. So now the total volume is equal to volume of first cylinder plus volume of second cylinder. Okay. Now volume is pi r square h. So I'll just take pi common because r and r are different. So I'll just say pi r square h1 or pi r square capital H plus pi r square h. Okay, this is the volume. Now I'll take pi common. R square h. What is the radius here? It is 12 into 12 into height. Height is 220 plus r square h here. So r is 8 into 8 into h. H is 60. So let's compute it. Pi as it is. 12 into 12 is, oh, we can take certain things common and compute it, but let's compute directly. If we take common, things will be easy, but let's compute it. This is 12 into 12, 144, 144 into 220. 144 into 220 comes out to be 31680. It is 31680 plus, coming is too big, 220 it's 220 centimeters height. Okay. Now 8 into 8 is 64, 64 into 60. 64 multiplied by 60. It comes as 3840. And if I add it with 31680, this comes out to be 3.14 into this value is 35520. Okay, this value into 3.14. So it comes out to be 103,315.2. So this is the volume, centimeter cube. This is the volume of this entire figure. Now they want to know what is the mass. Okay, for mass we have to multiply this thing with 8 grams. So let's multiply this with 8 to find out how many grams. It comes out to be somewhere around 799,641.6 grams. Okay, if you want to convert it into kilograms, so it comes out to be divided by 1000, it comes out to be 799.64 kilograms. Somewhere around this much. 799, somewhere around 800 kilograms is the weight of this entire thing. Okay. So coming to the next question. Again, figure is still not given. A solid consisting of right circular cone of height 120 centimeter and radius 60 centimeters standing on a hemisphere of radius 60 centimeter is placed upright in the right circular cylinder full of water such that it touches the bottom. Oh, how many things are there in this? A solid consisting of right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in a circular cylinder full of water such that it touches the bottom. Find the volume of the water left in the cylinder if the radius, okay, this is it. So first make the to understand this part. So first of all, we'll make this kind of question we did in the examples. So this is a sphere. And on sphere, there is a right circular cone. So this is a cone is on the top of it. So we'll just say this cone is on the top of it. This is a cone. Okay, this is the cone. Okay, this is it. Okay, the cone has a height of 120 centimeters. So this is 120. The height of the cone is 120. And the radius is 60 centimeters. This is 60 centimeter. Okay. Standing on a hemisphere of radius 60 centimeters. So again, the radius of the hemisphere is 60 centimeter and okay, is placed upright on a circular cylinder. So this is put on a circular cylinder. So this is cylinder here. Like this. Circular cylinder is touching the base. They mentioned is touching the base. Oh, the radius of cylinder is 60 centimeter. The radius of cylinder is also 60 centimeters. So the figure should not be, there should not be any empty space. So actually, there should not be an empty space actually. So let me make the figure correctly. So it is touching here. So basically the cylinder is like this. And when we touch it, so it will touch on the sides. It will touch on the sides actually. And then it is be cylinder. Oh, it is touching the base also. It's touching the base also. Let me just erase this part. I'll just make it again. Just make this thing again. So this is the cylinder here. Okay, so this is a cylindrical thing which is kept here and is touching the base of it. Understood? Now we have everything. What is the height? The radius of the cylinder is 60 centimeter and its height is 180 centimeter. 180. So it is 120 is this and this is 60. So the height is 180. So this height is 180 centimeter. Take pi is equal to 3.14. So what do you have to find? Find the volume of the water left in the cylinder. So we have to find, first of all, we need to find the volume of the shape inside. So this particular shape which is kept inside, first we have to find. So volume of that shape, volume of the submerged shape is equal to volume of hemisphere plus volume of cone, isn't it? The volume of hemisphere plus volume of cone gives us the volume of the submerged shape. What is the volume of hemisphere? Volume of hemisphere comes out to be 2 by 3 into pi into r cube. I just write it as r cube only. Okay, plus the volume of cone is 1 by 3 into pi into r square. R is same into h. So what is common here? Common is 1 by 3. Pi is also common. R square is also common. So what is left? It is 2r plus 1 by 3 is gone. Pi is gone. R square is gone. Only h is left. So this is the volume of the submerged thing. Now we need to subtract this volume from the volume of the cylinder. Okay, so we want to compute it first. Let's compute it and then we'll say this. We have to take pi as 3.14. R square, what is R? 60. So we'll say 60 into 60. And 2 times R is 120 plus height of, what is height of? Height of it is 120 centimeter. 120 centimeter. So it comes as 120 plus 120 is 240. That is 1 by 3. Or we can cut it 1 by 3 into 3.14 into 60 into 60 is 3600 into 240. Okay, we can cut 3. 12 3 is 1200. So this will be too much of cent. I have taken something, everything is centimeter, right? Okay, everything is in centimeter. So let's find out. It is, or we'll keep it like this. It comes as 1200 into 240. 1200 into 240. So it comes out to be 288,000 pi centimeter cube. So this is the volume of the shape. Now we need to subtract this from the volume of the cylinder. Volume of the cylinder. So what is volume of the cylinder? Volume of cylinder is equal to pi r square h. That is pi as it is r square. What is the radius for it? Radius is 60. So it is 60 into 60. And what is the height? It is 180. Okay. So it is 180. 80 into 60 into 60. It comes out to be 648,000 pi. Now we have to find the volume of water. So volume of water is equal to this value. It is 648,000 minus this value. It is 288,000. This is pi, actually, pi. Okay. That comes out to be minus 288,000. Comes out to be 360,000 pi. Okay, I'll multiply this with 3.14. So it comes out to be, once again, it's 360,000 multiplied by 3.14. It comes out to be 1130,400 centimeter cube. So this is the water. Okay, so or we can also say, if we have to take out, we know that 1000 centimeter cube is equal to 1 liter. Okay, now so we can divide it by 1000 and we can say it is 1130.4 liter of water. Okay, so coming to the next question. A spherical glass, again the figure is also not given. Oh, this is the last question. Good. A spherical glass vessel has a cylindrical neck. A spherical glass vessel. One second, where is my pen gone? Pen. A spherical glass vessel has a cylindrical neck. So it is a spherical vessel. I'll just make it. It's a spherical vessel. Okay, has a cylindrical neck. This is a cylindrical neck. I should make it straight. This is Tenameda. Cylindrical neck. 8 centimeter long. This is 8 centimeter. I made it too big. 2 centimeter in diameter. Okay, so that means 1 centimeter is the radius of it. The diameter of the spherical part is 8.5 centimeter. So diameter is 8.5. So I can say it is 4.25. 4.25. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. Check whether she is correct, taking the above as the inside measurements. Okay, pi is equal to 3.14. So let's find the volume of it. So volume, first we have to find the volume of the total volume. Total volume is equal to volume of sphere plus volume of cylinder. Okay, what is volume of sphere? It is 4 by 3 pi r cube. Pi into r cube. R cube is 4.25 cube. Plus, what is the volume of cylinder? Volume of cylinder is pi r square h. So let's say pi r square. R is 1 into height is 8. Okay, so pi is common. I'll just not take pi as of now. Pi is common. Or I'll say 4 pi is common. 4 pi is common. So what is left here? 8.5 divided by 2 is 4.25. 4.25, that's correct. So 4 pi is common. So it becomes 4.25 cube divided by 3. Plus, this is taken as common. 4 is common, so it comes as 2. Let's find out if the value comes out. What is the value of this? So what is 4.25 cube? 4.25 multiplied by 4.25 multiplied by 4. It comes out to 76.7656. And then we divide it by 3. It comes out to 25.58. So 4 into 3.14. Okay. And this comes out to be 27.58. Okay, I'll just say 27.59. It comes out to be 346.53. So she has done a correct job, actually, I should say. Okay. So this brings to the end of the chapter. Thanks for watching, and please subscribe to the channel if you have not subscribed. Thank you. Happy learning. Bye-bye. Take care.